A conceptual framework for understanding the cosmos abstract. This work proposes a conceptual model for interpreting the structure and dynamics of the cosmos based on the transformation of fundamental lines of force and cosmic energy. Within this framework, gravitational and magnetic forces are interpreted as two manifestations of the same energetic process, differing primarily in direction and dynamical role. Gravity represents the concentric concentration of energy toward material nuclei, whereas magnetic forces arise as expansive processes once these lines of force pass through the nucleus. This dual mechanism provides a unified interpretation of orbital structures at multiple scales, from atomic systems to astronomical systems, suggesting a structural equivalence between the microcosm and the macrocosm. Fundamental hypothesis. The central hypothesis of the model proposes that the same lines of force and cosmic energy that approach material nuclei in a concentric direction, manifesting as gravitational attraction, transform into expansive magnetic forces once they pass through the nucleus. In this interpretation, gravity corresponds to the inward-directed concentration of cosmic energy toward matter, while magnetism corresponds to the outward redistribution of that energy after interacting with the nucleus. These two forces are therefore considered energetically equivalent but dynamically antagonistic, differing primarily in direction, centripetal versus centrifugal. Derivative manifestations of the two fundamental forces. From these two primary energetic processes arise several secondary physical manifestations. Gravitational manifestations include gravitational fields associated with the concentration of energy, the formation and condensation of matter in nuclei, the determination of mass through the quantity of concentrated energy. Magnetic manifestations include the generation of stable positive orbital structures associated with electric charge, strong magnetic interactions capable of destabilizing systems, weak magnetic phenomena associated with nuclear radioactivity, subtle magnetic or thermal interactions responsible for the fine regulation of orbital energy distributions. Transformation of gravitational lines into magnetic expansion. Within this theoretical framework, the behavior of cosmic energy may be summarized as follows. When the concentric lines of gravitational energy, responsible for the concentration, condensation, and formation of matter, pass through a material nucleus and emerge from it, their direction changes from a centripetal configuration to an eccentric or redistributive configuration. These outward-directed forces correspond to what may be described as magnetic fields and magnetic forces. The resulting expansive magnetic forces, which may also be interpreted as orbital centrifugal forces, distribute, stabilize, and maintain satellites within well-defined positive orbits. The characteristics of these orbits depend on the dimensions and rotational velocity of the orbital system as a whole. Such systems include atomic structures, leptonic systems, planetary systems, stellar systems, and galactic structures. Orbital geometry and the cosmic spiral. In this model, orbital distances or radii depend on the scale of the orbital system and are determined by a cosmic spiral generated by the rotational motion of the system. Orbital positions correspond to the intersections between the radius of the spherical system and this rotational spiral structure. These intersections define the possible stable orbital distances within the system. Formation of orbital systems. According to the proposed cosmic model of unification, when particles or material bodies reach certain critical dimensions, such as those associated with the hydrogen nucleus in atomic structures, their magnetic fields become sufficiently strong to generate and sustain stable orbital configurations. In the case of hydrogen, this leads to the formation of a single stable orbital with sufficient potential to attract and maintain an orbital satellite. These satellites define the effective volume of the atomic system and contribute to maintaining an average cosmic energy density compatible with the global energetic equilibrium of the universe, which may be understood as an immense reservoir of energy. Orbital flexibility in subatomic systems. The formation of orbital systems may also occur in particles smaller than the hydrogen atom, such as leptons. However, in these cases there exists significant flexibility in orbital formation. Some particles may lack orbital structures entirely, as in the case of the positron, while others may exhibit excessive orbital volume relative to their contained energy. Such configurations typically correspond to negative particles characterized by a large spatial extension and relatively low energy density, which may represent deviations from the optimal cosmic balance of energy distribution. Structural equivalence between microcosm and macrocosm. A key implication of this framework is that the process of matter structuring is universal across all scales of the cosmos. The same principles operate at the level of atomic systems, atoms and electrons. Leptonic systems, leptons and neutrinos. Planetary systems, star-planet structures. Satellite systems, planet-moon structures. Galactic systems. Thus, the microcosm and the macrocosm exhibit a structural and dynamical equivalence, governed by the same fundamental forces, energetic processes, and geometric principles.